Final presentation of today before we go into a broader discussion of the issues and later on the gaming is from a colleague from NIAS, a larger Danish consultancy firm here in Aalborg, based just underneath our offices, or maybe vice versa, that we're based just above them. These we will later. And Denmark in general, Jakob Larsen, you are to present on the godsbane areas in Denmark. You call it railway goods area.
I tried to translate it. I'm not sure it's correct.
Under the sort of overall umbrella heading that we call green infrastructure, this is then one of the cases that we have in Aalborg and closures.
Well, this is an ongoing project that we're working on, and it's being constructed right now. It's going to be a bit more, what you call it, specific and technical than some of the other presentations that I've seen anyway. If you have some questions during the presentation, just stop, because some of the expressions are quite technical and they're obvious to me, but maybe not to you. So just ask. The area that we're working on is based here pretty much in the center of Aalborg. We are out here somewhere right now, but it's a pretty big area. I think it's 19 hectares in total, and it's an old, it's a railway goods area. I'm not sure. It's a place where the railway used to load goods on trains to ship out of the city. So it's being remade now into like a green city center, and the planning that we got involved after this plan was made, the local development plan for the area, which was made as a contest between different architects, and it was an architect firm called Polyform that won with this suggestion. And as you can see, there are pretty large areas of infrastructure, of park infrastructure or green areas, combined with a pretty densely built where people live. It's quite dense there, but it has an overall. It has a lot of green and blue infrastructure. I think, like, thought into it from the beginning, or at least that was the goal of it. These are some of the demands from the local development plan for the part that we were involved in, which was the water management part of it. There had to be separate systems for wastewater and storm runoff, and we had to be able to have a retention of the water corresponding to a runoff out of the area of 1 liter per second per hectare of total area, and the total area is 19 hectares, and the part we're working on right now is 7 hectares, which means that we can only discharge 7 liters per second from the area, and we have to make basins for the rest of the water. There had to be green roofs on all buildings, and we had to reserve 3,000 square meters for retention basins or ponds, and that was to live up to retention or a repetition period of 5 years for flooding from the basins.
Under a present climate scenario?
No.
Or a new one?
Yeah, and that's there are quite clear rules on that. You have some leeway, okay. And what you do is you calculate how much is needed today, and then you multiply it by 1.25, okay. And you hope that's enough. That's the way you do it. These are some of the key participants which was involved. Of course, there was the municipality, both. I don't know what it's called, but forsynings.
Utilities.
The utility company and the municipality as well. The entrepreneur, these were the overall owners of the of the area, there was the Danish Railway. They have a property development apartment, and these were two property owners that was involved from the beginning, and there was the architects, and then there was us. And because of the quite tight time schedule, it was very important to have a good collaboration between the different participants. And one of the things we did was we took a field trip to Malmö in Sweden, which has where there is a very similar a city park, which also involves a lot of these green and blue infrastructures. That was to develop good relations between all parties, and we have had a high degree of openness. We had a common web platform where we could upload drawings and notes and stuff. And there was pretty frequent meetings at the beginning. It was at least once a month, and that was to ensure fast decision making, so that if something was needed, if a decision was needed to be made, it could be made fast, so you didn't have to wait. Also because people, the Fjordblink and almost Studenterkursus was actually building their buildings as we were still planning how to do the water management, so it was quite hectic sometimes. The design of the area, there was a wish both from the entrepreneur, the architect, and the municipality for a high degree of blue and green infrastructure. And they had to be an integrated part of the area. And that was to ensure like optimal use of the pretty densely built area, so that they could basically to cram as many buildings as possible into a small area. There had to be direct access to park areas for the inhabitants, but also there had to be access to sport facilities. That was mainly due to this almost Studenterkursus, which is that's where you can take a degree, and someday I needed some sport facilities. There had to be open common areas between the buildings, and then we had to meet the requirements of the local development plan, of course. And in addition to this, we had to secure the area for climate change and extreme events, and that's a period of repetition of 50 to 100 years. So these were some of the difficulties or the challenges that we had to meet when we designed the area. So we started by we did a preliminary screening of the area. We had some inputs. This was mainly precipitation, and then we had some outputs from this retention need. And we looked into infiltration, but I have a picture. Just in a moment I'll show that infiltration is not possible, because we had a layer of clay near the surface, and there was possible pollution due to the prior use of the area. So what we had was, we had runoff to either the public system or a small stream that maybe is to run through the area. We had evaporation from open water tables in our basins, and we had evaporation from green roofs and rain gardens. These were the possibilities that we had. And this is just a picture to illustrate that infiltration isn't possible. This is a small lake or a small pond from groundwater being pumped up so that they can build around the buildings. And we looked at it in this concept where we had different from when the rain hits the surface to when it's at the end of the road the water takes. And there was source control, which is right as the water hits, which was mainly on the buildings, on the roofs. And we had on-site control, which was the open areas, and then we had the transport of the water, and then we had the downstream control, which was where we had to retain the water before we send it out of the area. And these are the solutions that we chose, which was, of course, the green roofs, because we had to. But in the open areas, we chose to have rain gardens and depressions to collect the water and from there lead it away from the open areas. And we had open channels to send the water to our basins or in our ponds, to ensure the blue and green infrastructure as a part of the city. But we also needed pipes and some surface runoff. And we had, for our retention need, we had wet and dry basins. I'm going to take each of these elements now and just give a short presentation of them, and then at the end I'll show you how they all work together. The green roofs, which is supposed to be at all the buildings, they have some retention capacity. We estimated it at 4 millimeters, and after this initial retention, the runoff from the roofs, we regarded it as any other roof, or basically the same as an asphalt surface after these 4 millimeters. And it's not completely correct, but since we don't know how they are going to build these green roofs, we didn't know yet, so we had to take a decision, and the retention capacity is very dependent on how you choose to build the roof itself. So that's how we choose to do the calculation. And also, these, when we design the systems, we look at heavy rainfall, and the effect from a green roof is limited when you have heavy rainfall, because it's like a sponge, and when the sponge gets filled up with water, it runs off like a normal roof. So. And we had rain gardens situated. Maybe just see them here. There's one. They're scattered all around the city or around the area. The wish from the architect was that they was to be used in pretty much all rain events. And we then added a feature where we could use these as overflow or pressure outlets from within in the area, and then lead the water away. So we connected them to stormwater pipes, which was below ground, so the water would run away from the building and into these rain gardens and depressions in the area, and from there be led to the retention basins. And this is a typical how they are supposed to be built, where we have the fall away from the buildings towards the rain gardens, and we also have the channels in the city or in the area where there's direct access to and from the rain gardens. And the channels and stormwater pipes was designed. The channels mainly was designed according to the architect's wish, where they wanted the channels as narrow and shallow as possible, which was quite a challenge because the area is flat, and you need some fall on the channels in order to move the water. So some of them got rather deep, but we did that. They were designed based on what we call it's called a rational method. It's a hand calculation where you just take the area connected to the channel upstream from the channel, and then you multiply it by intensity from a rain, a design rain, and then to ensure for climate change and other different unsecure factors, we multiplied it with a safety factor. The stormwater pipes was designed on a 5-year repetition period for flooding to ground level, and this was done in a model program called Mike Urban, and there we used a safety factor of 1.43, and the differences in safety factor is due to that with this program you can take more different things into account, so you need a smaller safety factor. These are the channels as they're being built. So you can see they are quite shallow, or quite narrow, but not so shallow. And this is how it looks when they're built. All the water from the roofs is supposed to be led to the channels, but some of the buildings were built prior to the channels being installed, so it wasn't possible, but from almost all of the buildings will lead their water directly into the channels, while some of the surface from this surface will flow to the rain gardens and from there to the channels or the pipes. And the retention basins were situated in this park area, and they're filled in a prioritized order, and that is because they have different functions when they're dry and when it rains. These three brown basins are a football field, or basketball field, and a beach ball field during dry periods, and the others, the greens, are sort of like different types of gardens. And we've made it so that all the green basins are filled first, and then the football field, the beach volley field, and then at the end the basketball field. And that was according to the wish from some of the property owners. And this is with a repetition time of, I think, once every year in average. This will come into effect, and it's around 2 years and 5 years for those basins. And in emergency or during extreme events, all of these basins can overflow to the rest of the park, which is lower than the rest of the system. So we have like it's like an emergency basin, an extra volume that we can use. And one of the things you also have to take into account is like cleansing of the water, because as soon as water hits the surface, it's by definition it's polluted. So at the end here of the flow, we have a cleansing basin where the water comes in, and we have small, maybe you can see it's like small dips up, and water has to flow over them, so you get sedimentation in these zones of the pollutants, and hopefully the water is clean when it comes out the other end. And how does all of this work together? We have all the channels around the buildings leading the water away from the city center or away from the area, and they're connected to all of these rain gardens, which in turn is connected to an underwater pipe system, which also is connected to the park area where the basins are. So it's like everything is connected, and in the pipes the water actually flow upwards and downwards and up into the basins as the pressure builds up in the city center during extreme events. Yeah, and here's just the same picture where we have. So the waterways are mainly in the channels out into the park area where the basins are, also via the rain gardens. It's a bit confusing, but it works. And this is the situation that we had to avoid. This is from Copenhagen about 2 years ago, and this was not desired for the area, so we had to. That's why we had to make all the different parts connected. One of the problems or the difficulties is that there was a ground level access to all the properties, and when you've got ground level access and you've designed the area for surface runoff, it could be a problem. So what we did was we used a tool called MyFlood, which can model both the pipes, the channels, the basins, and surface flow, the surface runoff at once. And then this is used to, we call it local climate change adaptation on property level, because we are able to go in and pretty precise design the what ground level should be in front of different buildings. And this is the result of the preliminary the first calculation. And you see we have some problem areas here where the water runs along the building out into the street if you have an extreme event. So this was not something that was supposed to happen. So then we were able to go in and design the ground levels around this building to avoid it. And we also tried to use a rain that flooded large parts of the city about 6-7 years ago, and see how the system reacted to this. And as you can see, all the basins are filled, but also the rest of the park are filled with water. So, and the city center, the city area is pretty. The only places we have water is the places where we want to have water. So the system worked as we had hoped. So that was a nice result to get. And this is how it is, how the progress is now. I think here now there's a building being set up with elements, and this part of the park is starting this spring to be built. So there's a lot going on down there still, and you can go down because people live there, so you can go in and around these buildings and watch what's going on if you want to. We've also made a small YouTube video just describing the process of how the area was designed. It's in Danish, unfortunately, but yeah. Okay. That's it.
So, questions, comments?
I would like to know if this is only an initiative that is taking place in Aalborg right now, or are you considering to expand it maybe to other cities like Copenhagen?
This was, I think mainly the initiative came from the municipality, but I know there's a lot of things similar to this going on in Denmark. I know of a big project in Roskilde, where they are using, they've built a big skate park, which is also basins in these half pipes. So there's a lot of things going on right now where you think the double use of areas in. And Copenhagen is trying something similar, but it's more difficult because it's so densely built. So I don't know what I think some of the solutions in Copenhagen are just building bigger pipes and maybe generating what we call it, like ways for the water to run, like in the street, to get away from the areas.
This is basically taking place after what happened 2 years ago.
Yeah.
You see like an increased tendency.
It's over in Copenhagen. It's a lot more is going on than in Aarhus or Aalborg right now because of the rain. Like you talked of a sense of urgency. Just have the biggest rain you've seen in 100 years fall in your capital. You'll get a sense of urgency.
So you had an example from 2006 where there was heavy rain in Aalborg, but I mean, what's the worst scenario that you're planning for? Because that rain in Copenhagen 2 years ago,
Yeah.
which basically wiped out the other half of what I had in the basement from the year previous, where there was also a flood.
Yeah.
It's going to get much worse. So are you planning for, things that are twice as bad as what happened in Copenhagen 2 years ago, or what? Because if you're looking at 100 years and things are only getting worse and worse and worse.
Well, what we do, we do this. We use these. They're called CDS, Chicago Design Storm, which is basically a generated rain based on a lot of statistics on the measurement that we have over the last 30, 40, 50 years. And then what we do is we say this is a 100-year event now, and then we multiply that by a factor which is based on some calculations done on the IPCC calculations.
On the
how
IPCC calculations are like from 2007, or
Yeah.
whatever. Everything's old.
Yeah.
But I was trying to say, what happened in 2012 is that things have, it's a hockey stick. It accelerates like this.
Mm.
See, you don't have any calculations. Anything the IPC has said, I think they're coming out with a new report.
Yeah.
But even that report's based on data that's up to 5 years old. Things are going much, much faster. So my question is, why not calculate for something that is 3 or 4 or 5 times worse than what Copenhagen experienced in 2011? And that way, maybe in 20, 30, or 40 years, that event will happen, but you'll be able to take care of it.
Well, that's you have to at some point you have to say that there are just events that you can't like completely protect yourself against. So what we try to do is generate like ways for the water to get out of the parts of the city. But there will be events that will happen that will flood some of this area as well. This what we've shown as to what is now 100-year events multiplied by 1.4 or 5, I think, is okay for the area. But who knows what a 100-year event is 100 years from now? Because well, as you also say, the IPC and the data used to decide what the safety factor is it's very it's only based on one report. So, but that's the data you have.
But a follow-up question on that could be if you have been thinking adaptive management, where you think in flexible solutions that if you experience in 20 or 50 years that the events are going to be much larger than you expected, that the solution will be easier to build like higher or wider or to contain more water. Is that something you've been looking into?
No, not really. No. But what you could do is just, I don't know, it sounds stupid, but just like raising the level around the properties. But there's a lot of regulations you have to take into account with access for handicapped people. So that's usually what, because you could just put in a block of cement around the entrance and you're pretty safe, but that's not allowed. So.
Yeah, at some point that would overflow as well.
Yeah, but the channels and the pipes, and they're pretty difficult to adapt. What's they said, it's like, this is how it is, and if we have to change it, it's going to be expensive.
Yeah.
But it's a fun thing. Sorry, Peter. But it is an odd thing because you're looking back, you're looking for statistics, but we don't have statistics that cover what we are going to see. I think that's basically your message as well.
Yeah.
David Major, who was here in March, was saying more or less the same things, right? That we have to be able to forecast, and we will have to develop scenarios, and these scenarios have to be developed on basically what you're saying. Well, at some point there has to be an acceptance that things will happen. What is it that you're working with in terms of your flooding? 10,000 years storms. But hey, if it came last year, so it will never happen again. Okay, fine. And then it hits again, right? So what is a 10,000 year storm? Nobody knows.
Well, that's
what do you do?
we always base your statistics on
But you don't
previous
have,
measurements.
yeah, but you don't have statistics. You have to forecast now. You have to model and forecast. That's the problem.
And what
You
we
have
do-
to change.
What we do is just multiply by a factor.
I just want to say the 10,000-year storm, that was the story of Noah's Ark. Literally, that happened 10,000 years ago in Turkey. Huge rain and it broke everything, and then, you know, the water started flooding. But that was 10,000 years ago.
Lisa?
Yeah, I wanted to ask, when you calculate, when
when you do simulations with rainfall, do you calculate water coming from other properties in your calculations? Because when I look at the mappings, it's like the flooding just stops.
Yeah, well, we haven't in this particular simulation, but we are situated higher. All of this is situated higher than the surrounding area.
Okay, but how do you... But then you're taking care of the flooding within your property, because I'm a bit scared. I live just across the road from that area,
Yeah.
and if my house gets flooded in the basement from
Yeah.
the water running off, because you didn't calculate for that, is there anything telling you how far you have to look at the water?
Not in this calculation,
No,
but there's this year all the municipalities have to make a climate change. I can't remember the name. but something. And they are hiring the utility companies to look into this. So this is done only for this area, but you could do the same for the entire city.
but it requires that someone tells you to do so.
Yeah, because it's a lot of work and
And you don't work for free?
no. but also like this area, what the previously this area without any retention sent its water out through a big sewer pipe that runs right here. And during these like extreme events, what we've done is with making this retention, we've basically reduced the amount of water in that pipe. I think it's around something like 1,000 liters per second or something. So in that way we help. But this isn't. We've only looked at this isolated
Yeah.
in this particular case.
But the reason for that I asked, because in previous projects I've done, I see this tendency of you only calculate for the water within the area you look at, and it sometimes seems obvious for me that why doesn't the municipality go in and create synergies between these very local projects and try to synchronize on a municipality?
So this is a kind of, because this is the water system in this will be privately owned by the.
Yeah.
But normally, if I don't know if you're going to do a renovation of the sewers out here, we would take pretty much all of the city in to take account of different things flowing together. You have to do that. But this is isolated, so we're able to do it just. But you're right. People only, and that is a tendency. Also that, like different property owners are designing and doing measurements so that they don't get flooded. But all they'll do is just send the water to the neighbor, and then they have to take their own measurements.
Yeah, it was relating to Peter's project that he presented earlier, and the recreational value and ecosystem value. Do you know what kind of property value increase that they can expect in this area for like the value of the blue and the green that you will implement?
No, I saw once some calculations done, but not on this area. But I think it was from Aarhus. I think it was around 10 or 15%. And that will also affect the properties, like surrounding properties. But and also this. This is a stream. It has been changed, so now it will come this way in, and this will go all the way through the city. And this is they're doing a socio-economic calculation on what will the benefits be versus the cost. So that it is being done, but I don't know what the results are.
Maybe we have a colleague here who can tell us about it. You don't know?
I think I've been working for that for 10 years.
That's the opening of it, so, yeah. Nothing really.
May I have some like example like to add on her question, like example on Thailand case for the flood crisis that like is the water starts from the northern of Thailand and every province try to protect their own city, so building some wall, so the water is just stronger and stronger when going down. So at the end, the impact for the last city is the worst case because it has the like fastest flow, something like that, because of protection from other cities. So without planning for the connection with other cities, it may create bigger problem in the future. But I understand.
Further comments or questions? No? Yes? No?